Welcome to Eye on You. Humans have been long manipulated genomes through selective breeding, choosing organisms with a desired trait and producing offspring with those desired traits. We have done that for thousands of years. But now, gene technology, also known as genetic modifications, provide ways to change genes and the genome. Modern medical technology has decoded the secret of gene, including pathogenesis of human disease, to identify human disease genes using established and emerging technologies to spot and to cure rare medical conditions together with drug development.
The Hong Kong Innovation and Technology Development Blueprint recommends that the government focus on promoting the development of life and health technology industry as a two-way platform for the nation. The Hong Kong Institute of Science and Innovation, CAS, cooperates with the King's College London, which is quite prestigious in the medical field, to establish a joint laboratory to contribute to Hong Kong's medical research. In this episode, we are glad to invite Professor Richard Trembath, the Senior Vice President for Health and Life Science of the KCL, who has experience in in-depth research in the identification of disease-causing genes and the treatment of special disease, to talk about the issues concerning human health and cutting-edge medical technology.
Hello, Professor Richard Trembath. Welcome to our show today.
Thank you very much. That's very kind of you.
So, as we all know that the King's College London is ranked 4th in globally and 1st in UK in the field of medical technology. So, can you briefly introduce us what's the latest achievement in KCL?
Yeah, sure. Well, we're actually very, very pleased with our position in medical technology. It's an area that we have, as a university, invested in over quite some period, at least over a decade now, but we've made rapid advances. We have historically really deep expertise in all specialties in medicine. But we recognize that one of the rapidly advancing areas is the way in which we can use medical technology to really drive a much more precise way in which we deliver healthcare. And one of our major achievements in more recent times is our ability to capture much more detailed imaging of patients, whether it be of the brain and in particular the heart. We have a very large population where we treat patients, young patients with heart malformations, disruption of the way in which the heart is formed. And this requires surgery. And the surgeons have benefited from our advances because we now can print the heart of the child before the surgeon operates, a 3D print. So the surgeon can hold in their hand exactly the structures that they then will be operating on. And this has transformed the way in which they can achieve very good outcomes for these patients. That's just one example, but it's a very prominent example that I have to say the parents of these children feel so much more confident when they know that the surgeon is going to be able to anticipate exactly what they're going to have to do rather than waiting until they are operating themselves.
Right. I know that the main purpose for your visit here to Hong Kong is to attend the launch ceremony of the joint laboratory, right?
Yep.
And why did you choose Hong Kong? And is there any advantages that we Hong Kong possess in the biomedicine?
Well, look, these collaborations, international collaborations, are something that is very important to a university like King's College London. We are an international, globally outlooking university, and we can only achieve the positions of prominence by selecting and choosing our partners very carefully. Now, some of that is driven by already established relationships. In this instance, actually, one of the chief investigators in the centre here in Hong Kong had previously been with us in King's, and we therefore knew this individual very well. But actually, we also looked at what were the opportunities, the synergies between our area of expertise that I was just reflecting on and the expertise that sits here. And again, historically, Hong Kong has fabulous universities, But what, of course, Hong Kong has done very well in the same period is taken the ideas from universities to develop them and translate them so that they could be used in practice. And in the area of artificial intelligence, and in particular combining AI and robotics, Hong Kong has some really remarkable strengths, which of course also reflect on the position globally that Hong Kong presents here in the wider China arena, and the opportunity, of course, for us to interact with Hong Kong, but take advantage of its position and all of the facilities that it can access from wider China, makes a very, very interesting partnership for us.
So the Hong Kong government has just released the latest innovation and technology development blueprint in last year, November. So how do you see the opportunity between Hong Kong and KCL in the coming time?
Yeah, so I think it is this synergy, the idea that we have deep expertise that is very much founded in using patient experience and our facilities. We have a very large patient population across all of the specialties, but we have developed facilities to allow the testing of new mechanical and medical devices and the ways in which we undertake procedures using AI to optimize those procedures. We have developed facilities in the hospitals to assess these. The ability here, of course, is the deep understanding of AI, its fundamental components and how we could more rapidly translate these activities, combined with manufacturing expertise that sits in the broader Bay Area, and of course the commitment that now exists through this blueprint to support such translational efforts. I was delighted today to have the chance to visit the Science Park, and it's truly impressive. I was reminded that, of course, the Science Park is sitting on what was ocean, not so very long ago, maybe 2 decades ago, and now it's populated with such an expansive group of people interested in translation, but taking advantage of its global opportunity.
So the KCL has many global partners at the field of medical biology. Can you share with us why did you choose the Hong Kong Care Center to partner with them, and what do you expect for the future cooperation?
Indeed. Well, we do have many partners, but I might say we are very selective about our partners. In this instance, as I've said, the deep expertise in AI, which we also hold at, in London and certainly at King's, but the intensity, not least through the Chinese Academy of Sciences and its commitment to fundamental aspects of AI, bringing that into the proximity of the efforts we're making now in using artificial intelligence and robotics to advance our ability in medical technologies. What are we looking for? What are we hoping for over the next period of time? What we would like and what our ambition is that we want to make sure we're training the next generation of investigators who will be developing these products over decades to come. So training and an opportunity to exchange in young early career academics, PhD students. It's a critical opportunity for us to expand their expertise very early in their career. Of course, second to that, we want to move these ideas forward and into medical practice far quicker than we would do if we were not partnering.
And also, can you tell us your vision and the phased implementation of the newly established the joint laboratory?
Well, we see this really as an opportunity for us collectively and in partnership to be world leaders in this, both in terms of being able to attract perhaps some of the most outstanding students who want to work in such an environment, to have that opportunity to move between London, our university, and the centre here, and expand their own ambition through that. Of course, that means we're also providing very well qualified individuals to go and populate around the broader community, the global community, which again will be important in helping accelerate this sort of domain. So I think it is that we wish to be, in partnership, seen as a global leader in the use of AI, robotics, and advancing medical technologies to improve patient care. That's the fundamental thing, of course. Yes, of course, we need to generate resources, and the economy needs to drive but ultimately we're interested in supporting better outcomes for patients.
We would like to also talk about genes. So genes are like a group of interlocked data, and just a tiny bit of mutation will cause a lot of problem, and there are a lot of disease caused by genetic defects. So what are the current approaches that we have to cure such kind of disease, and how promising are these kind of approaches?
Now, how long have we got? I could be talking on this one for many hours. I'll try and be brief. I'm a geneticist, so thank you for asking. My own area of expertise is in exactly just as you describe how our genetic material, and in particular how variation in our genetic material can make us more or indeed less susceptible to a whole range of illnesses. Indeed, even during the pandemic, we discovered that there were certain bits of the genetic material that either led you to have a worse outcome from the infection, but also particular bits of the genetic material, certain genes, that if you had a particular set of variation, you were less likely to develop severe outcomes. And this is replicated across a whole range of diseases, some of them very common, heart problems, high blood pressure, others extremely rare, and I have spent much of my career working on both common things, skin conditions in my area. Acne and psoriasis have been two big areas for me, but also some very rare conditions where it's been a real privilege to work with families who have these severe illnesses running in the family, which is of course a real tragedy for many families, and being able to work with them to find exactly which bit of the genetic material is altered that is causing this. Now, of course, ultimately what we want to be able to do is take that information to develop new treatment approaches. When folk talk about genetics, they get confused sometimes as to the only treatment therefore will be the ways in which we might manipulate or change the genetic material. Now, those techniques, of course, are now rapidly developing the opportunity for us to think about changing the genetic structure. But it also is true that through genetics, we have learnt so much more about the causes of illnesses that we can better use currently available medications for certain groups of people with a condition. And also we can think about developing new treatments that are standard drugs, but using them in a much more targeted way because we know exactly what it is we need to alter. So the future actually is incredibly exciting, and the real possibility here is how do we join up those advances in genetics, which have come about not least because technical advances, the kinds of things we've just been talking about, have allowed us to read the genetic material, to sequence DNA at very considerable scale. So when I started to sequence your genetic material, it would take one PhD student 3 or 4 years. We could do it in 36 hours now, and at a cost that is manageable. So we can think about doing genetic sequencing on large populations, and the opportunity to link that information with improvements in the way in which we image the body, understand alterations that are occurring, linking up that genetic information to actually how our body works, and thereby having a much better understanding of what it is that drives illnesses, either through genetic alterations or as a consequence of the environment working with those genetic alterations. So there is just such a wealth of possibilities. I rather wish I was maybe 20 years younger, because there's plenty to do.
There's still plenty to do, even for now.
We still have time.
We still have time. Thank you so much for your time.
Thank you.
That's my very great pleasure. Thank you for hosting.
Hope that you can come back to Hong Kong very soon.
I look
see
forward
you
to
soon.
that. All
Thank
right,
you so much.
Thank you very
you.
much.